we're gonna finish off this section of the oxidation reduction reactions. What I'm going to do is I'm going to tack on at the back of this, because some syllabuses cover the half reaction table and the study of endo-exothermic or spontaneous reactions, which we'll talk about in a second. Some prefer to do it next year, some do it this year. But what do I mean by spontaneous or not spontaneous reactions? Just very quickly, if something's spontaneous, it happens, doesn't it? People burst into applause. It's spontaneous. It was a great show. So there's a spontaneous gesture, if you like, right, of happiness, right? Not spontaneous would be you have to force it. Somebody's got to run around shouting at people, clap now, laugh now, laugh now, which is what you often get when they're doing TV recordings, right? There's the people at the front with the things saying, laugh now, do this, do that. These days, I think they use canned laughter in most of them, because the other day I heard one of the TV programs that I love, and they played it without the soundtrack, or rather the laugh track. So you heard the voices and the one-liners, okay, but without the laugh track. Well, it was, I can't think of the exact word, but it was pretty, it was weird indeed. Okay, right. Let's have a look at now these half reactions and so forth. We looked at that. Let's just have a look and say they give us this reaction. Okay, let's just have a look here. Make sure I'm on the right one. They give us AgNO3 plus HCl goes to, and they say AgCl plus HNO3. Okay, this is what they've said has happened, and you can see what has happened over here. Let's have a look. The AgNO3. Let's have a look at what has happened with our numbers here. AgNO3. Let's have a look. Let's split it apart. AgNO3. Aha, oxygen. That's the one that we're going to start with, isn't it? So we say, right, you are -6. The nitrogen and the silver is +1. The nitrogen +5. Okay, there's our balance. So we end up with, okay. Now remember, that's balanced out, but just have a look over here. Is +5 -6. There you are. It's got the -1 on the outside. Okay, that is the polyatomic ion, the NO3, isn't it? It's a -1. So let's have a look at the hydrogen, shall we? Chlorine is electronegative, -1. Hydrogen must be a +1 because there's no charge on the outside. Ag is +1, Cl -1, Ag +1. NO3, HNO3, we've got our +1. The NO3 again is the -1, the whole ion, right? So can you see in here, none of the elements have changed oxidation numbers. They are all still the same. Because in there, in the NO3, the silver was +1, the N was +5, and that was -6, right? You can see in here, we've got exactly the same situation, right? We've got the H is the +1. Can you see the silver? Let's just highlight it a little bit. The silver stayed the same. The Cl stayed the same, right? The H stayed the same, right? And in fact, if we just look at it holistically, the entire NO3, I just want to, over there, goes to this NO3 over here, right? All right? So you can see there that the NO3, none of the elements' oxidation numbers have changed. What does it mean? That means it's not an oxidation reduction reaction. There wasn't a transfer of electrons, okay? It was a different situation, okay? Let's have a look at one where there is a transfer of electrons, and do a little bit of these are the examples that I said we were going to do. So, as I said before in the intros and things, your best result is actually take it down, put in the notes as we go, and put your own explanations next to it, right? Let's have a look here and say, all right, there we go. Zinc solid is put into HCl, okay? Right, now already you should know what we get, okay? What have we got here? We've got a metal plus an acid, gives us metal salt plus water, doesn't it? Or hydrogen. Which one? Metal salt plus hydrogen. We know the gas comes off. Remember in the experiments that we do. So we say we've got our metal salt, ZnCl, 2 plus H2 as a gas. All right? So let's assign oxidation numbers to this. This is the metal salt plus hydrogen, right? And if you're unsure of that, always just remember when you put the sodium, the metal, onto a water, the hydrogen was the gas that gets given off, right? The potassium, that even ignites it sometimes, and you get the popping explosions. Let's take this one and let's put in the oxidation numbers. Well, first of all, what is the oxidation number? Zinc solid. Hang on. The zinc's oxidation number over here is 0, isn't it? This over here, the HCl, is aqueous. I haven't balanced this, okay? I haven't balanced it, okay? Let's just put in the balancing number. H2, there's a 2 HCl, Cl2, H2, right? There we go, balanced. But just for the moment, what is the Cl? It's the electronegative, so that's a -1. So the hydrogen is a +1. I'm just going to remove the acid metal tags on top, and I'm going to put my -1 and +1 there, all right? And let's just put the zinc up top there, all right? Because generally, conventionally, we do it at the top, all right? Okie dokes, let's have a look now, all right? Let's just take that down a wee bit. Now, what has happened to zinc chloride? Well, chlorine is more electronegative than zinc, so therefore we say, here we go, Cl is going to be the -2. Therefore, there's no charge on the outside, so the zinc must be +2 because those must add up to 0. There's no charge. It's a compound without a charge, right? The hydrogen is now an element because it's a gas, so it's become a 0. All right? We're just following the rules. There's the zinc was the 0. Now let's have a look what has changed and what has happened. Well, let's take the hydrogen first, right? Well, what happened here? Hydrogen has gone from +1 to 0. So therefore, it has decreased. Okay? Decreased means it must have got an electron. Isn't that so? So how does it decrease? It had to gain electrons, gain Rig reduction. Okay? Now, let's have a look at the other side of this and said, well, what happened to this? Hang on, what happened to the chlorine? We say, now we need to just be careful here because I didn't multiply it by the 2. You can see it's -1. There it's a -2, but the 2 on the outside here. Okay? I need to multiply that in. So let's multiply it in. That would have been a +2, a -2, right? Now you can see that the chlorine, okay, didn't change its oxidation number. The went from +2 to 0. Okay, so it decreased by 2. So it got 2 electrons, didn't it? That's how it could. It's the only way it could have gone from a +2 down to that. We had 2 hydrogens, each one got an electron. That's what really happened there. If we just break it down, we had an H and an H. Those two, remember, at this point here, they came together at the activated complex and they formed H2, right? Now, what happened then? The chlorine didn't change. Let's have a look at the remaining one. The zinc. What happened to zinc? There we go. Okay. Zinc increased. Okay. Increase, it means it must have lost electrons. Okay. Oil, rig, oil, oxidation is loss. Okay. Therefore, the chlorine, what was the chlorine in this? Well, if you remember, we had something called a spectator ion. Okay. What does it do? Fundamentally nothing. It doesn't take part in the react. It just basically was dancing with this partner and suddenly was dancing with someone else, right? It just changed its allegiance from one to the other. That's all it did. Okay. So you can see here with these oxidation numbers, okay, that if you follow the rules, it's really not that difficult. You've just got to take it step by step and work it out which one has gone which way. All right. Now, let us move it now to a far more comprehensive and a much more difficult situation. All right. We are now saying they give us a reaction. It's in this case is going to be this. Whoops. Sorry. I'm just going to go back over here to black. They tell us that yes, we can balance the electrons. Okay, let's look at a reaction where we've got Fe iron, solid, 2 plus 3 Cl2 gas. This is iron and a chlorine gas going over it. All right, and yes, it's obviously going to have an effect on it. FeCl3 solid, and I'm going to put in the balancing number here of a 2. All right, but now I want to work first off without the balancing numbers. Okay, so I'm going to just for a moment just identify the half reactions which are unbalanced, because then you'll see how the electrons work out that we need to balance out. So what has happened here? The iron, right? The iron solid has gone and it's formed with something else. So the iron solid, when it went through there, the activated complex, it must have split and become an ion, okay, that we're going to use. And in this case, it's going to became Fe plus 3 and plus 3 electrons. Let's put an oxidation number 0 there. Chlorine is -1, -3, therefore that must be a +3. Let's just go through that again. 0, why? Because it's an element, right? Let's look at it on the other side. We need to work it out. We don't know it. But we know it's got 3 Cl's, and we take the Cl is the most electronegative. So that gives us a -3, so it's Fe plus 3. So you can see here that it's gone, right? Which means it must have gone from 0 to 3. The oxidation number has increased. How does it do that? It gets rid of electrons. So we've got 3 electrons were given away. And we can see here, okay, loss of electrons is the oxidation. Okay. Let's have a look at the Cl2, remember? Sorry, my bad there. Cl2, okay, was a gas, but now it's changed. It's now become, it's linked onto something. So it must have become a Cl minus to do so, right? But we've got 2 Cl's there, so we have to get, remember, each one of them splits and becomes an ion. That's why it's at the activated complex. We split the Cl2 apart to become a Cl and a Cl, and each one of those becomes a minus, right? So what has to happen here? Well, on this side, we've got some electrons that are given away, right? Let's just have a look at oxidation numbers and have a look, see. Let's have a look. Chlorine here was 0. Over here, chlorine was -3. Okay, so you can see we've gone, okay, it's changed to a negative. So that is the electrons have gone away. All right. So chlorine on its own would have split, and this is important to look at. Chlorine would have split as to a Cl and a Cl. That's how they are in the activated complex, isn't it? A Cl and a Cl. What do we do here now? The Cl has become a Cl minus ion. How did it do that? We had to add an electron to it, didn't we? Otherwise it would have stayed a Cl. Remember, the Cl has now gained one. Okay? So, hence rig, reduction is gain. So there's our reduction reaction. Okay? And ditto here, one electron. I keep putting an E plus because I'm adding it. One electron minus plus the Cl gives us a Cl minus, and there's the 2. Okay. Now, I just want to let's just move up a little bit here. All right. Now, what we need to look at now is we need to say, okay, but hold on. You can see that on the one side we've got 3 electrons, can't you? On the iron, the Fe side, there's 3 electrons there. On the chlorine side, on the left side, there's only 2. So we have got an imbalance of ions, of electrons. Okay? What did we say? We can't have that. We have to balance the electrons out. So therefore, let's just write it, Fe. Okay? We've got Fe, solid, went to, if we remember, we went to Fe plus 3 electrons there, and we said that we had 2 electrons plus Cl2 gas became a 2Cl minus, right? This is at the activated complex. It's now on the other side. We've got our products here, haven't we? And we've got our reactants this side. Okay, like that. So what do? We say, right, now in this situation, we've got to balance the electrons. Otherwise, we've got electrons hanging around, and we can't have that. So we take equation 1 and multiply it by 2, equation 2 and multiply it by 3, because essentially we've got 2 simultaneous equations, so we're going to change this to a 2, and a 6. Let's do the same at the bottom. Now we multiply by 2, and the bottom we times by 3. So we're going to get 6 electrons here, 3 there, and over there it's going to change to a 6. Right? Therefore, let us now just draw the line over here. You can see I'm not going to write them down, but the electrons are going to disappear, aren't they? They're going to be balanced out. So we end up with 2 Fe solid plus 3 Cl2 gas going to 2 Fe plus 3 plus 6 Cl minus. Now we can add those together, because what happens is we've got the Fe and the Fe, 2 of those, right? And remember, each one gets a Cl, because it was FeCl3. So therefore we've got 2 FeCl3. All right? Very simple, very straightforward. Now, the last one that we're going to do is far more complex. All right? Before we get there, there's one thing that you need to put a little NB. Okay? Remember, we balance electrons, don't we, in these? But we can add H2O if it's aqueous. 2, right? Very important. Add H plus if it is acidic. Why? We know if we know something happens in the presence of an acid, we know that there must be H plus ions in there floating around. We're not absolutely sure if there's always H2O, but definitely there's going to be H plus ions. If there's H2O as well, then we're going to get an H3O plus, aren't we? The oxonium or hydronium ion. Let's have a look. And the third one, well, obviously OH if it is alkaline. So we add in order to balance the reaction out. Because as you'll see in this one here, this is quite a long one. So maybe just let's go through it together. Okay? Let's just say, right, they tell us that the ion here, Cr207 minus 2 plus hydrogen sulfide, H2S, goes to a Cr plus 3 plus sulfur, and it's in an acid medium. Which means already it tells us that we're going to be up there. It's acidic. If they said alkaline, we'd have put in OHs. Okay. Now in this case, we say, all right, let's just see what happens. Let's assign oxidation numbers, right? First of all, let's assign to H2 and S. Well, okay, the sulfur is the most, so it's minus 2, and there's a plus 2, right? Let us now go over, okay, let's have a look. The S over here, oh, it's gone to a 0, hasn't it? So immediately we've got an oxidation reduction reaction, because the one oxidation number has now become an element. It did have a minus 2, it's now gone to there. So what has happened? It has increased, isn't it? Increased oxidation number. Okay, so let's just take that half a reaction out and say this is our half reaction. We had S minus 2. On the other side, we've got sulfur, right? So what happened is it had a charge of minus 2, it's got 0, so it must have lost 2 electrons on here. Okay? So it's lost electrons. Okay. Now, let's have a look at the Cr207 ion, right? Let's assign some oxidation numbers here. Well, let's do it I'm just going to do it just above, okay? Cr207, and on the outside is a minus 2. What did we do? We said, right, oxygen is more electronegative than chromium. Therefore, we assign that as a minus 2 times the 7 is the minus 14. All right? Now, therefore, the chromium 2x minus 14 must equal minus 2. So we say 2x minus 14 must equal minus 2. Therefore, we get the chromium coming in at plus 6. So plus 6. So let's put him in as plus 6. And the oxygen is going to be minus 14. Now let's go to the other side. Chromium is plus 3. Okay, they've told us that. It's a chromium plus 3 ion. Right? So this is, whoa, what has happened? The reduction, the oxidation number has been reduced, hasn't it? So we've got chromium going down there, increased oxidation number. But now we say, okay, well, hold on. Okay, Cr2, okay, we must have done something to have changed that. So yes, we have added electrons, haven't we? But guys, what happened to the oxygen and the hydrogen in this? Can you see it's not on the right hand side? It's disappeared. They are wanting us to solve for it, to find the correct half reaction. I hope you can see that essentially, so let's just look at it again. The hydrogen, I'm just going to go to blue. The hydrogen, there was oxygen this side, there's no oxygen on that side. There was hydrogen this side, there's no hydrogen. So the hydrogen and the oxygen, where are they? Now we know from all of the work we've done that they must still be there somewhere. Now we've got to go find them. Okay? This is the most difficult part of this, right? Is we go find them. So we say, right. We write down our reaction and we say, okay, sorry, I just want to go back to start at black. We've got Cr207 minus 2 has gone to Cr plus 3. Okie dokes. Well, first of all, we start with oxygen and we balance it out. Remember, it's in an acid medium. So acid, we're going to add H plus at some stage, right? But you can see that over here we've got 7 oxygens. Cr207 minus 2 and Cr plus 3. Now what am I going to do? Okay, I'm going to first of all change and I'm going to put in, what do? I have to add water. So I'm going to add 7 H2Os. That balances out 7 oxygens to 7 oxygens that side. We start with the oxygen first, we bring in water. Okay, this is the recipe, this is how we do it. We start with the oxygen, we bring in water to balance it out. The next step is we say, okay, we've now balanced out the oxygen, but now we've got 14 hydrogen ions on the right-hand side, on the product side. So what have I got to do? I've got to balance those out. We've got to add them in on the other side, haven't we? So, in fact, let me just write it down, rewrite. Cr207 minus 2, Cr plus 3, plus 7H2O. Okay, so first of all, we balance oxygen by adding water, H2O. Okay. Second step, we balance hydrogen by adding an acid. Okay, how are we going to add the acid? Let's make it red. I think that's quite cool for it. Red, we are going to add in 14 H plus. Okay. Right, now we've got quite a lengthy expression, haven't we? We've got that. Now what do we do next? Well, next we say to ourselves, okay, now the last thing is we have to balance out the chromium. Okay, well, we know that we've got Cr2, so there's 2 Crs on that side. Okay, balance the hydrogen, and last, balance the Cr. 2 of that side, now we've got 2 that side, right? Then we say, righty-ho, the next step, okay, we've added stuff in, haven't we? But we haven't balanced the electrons yet. We're still getting to balancing the electrons. Okay, that's why this is a long one. We added stuff. We need to check out the electrons. Well, what have we got? Okay, well, on this side, over here, let's do it in blue. What have we got? We've got 14 positives and 2 negatives. So this side we've got a 12 plus, and on this side we've got a 6 plus. Therefore, I've got to add plus 6 electrons here, over there. Right? The last step is balance the charge. See? 14 plus minus 2. This side the only charge is there, plus 6. Okay. 14 minus 2. You see that? All right. That's that we're balancing the charge. Now, how do we balance? Well, we got 12 plus this side. I only need 6 plus, so we must add in a -6 charge, which is 6 electrons, isn't it? Okay? In order to reduce it to be equal to the right-hand side. The final step is then we can write down the reaction for this. Right? Let's just write it down again. I want to now go back. I want to say, right, we found the other half reaction. So let's put down that we've got S. I always forget. Remember, we started off with the S minus 2, which was the easy one to find. Went across to S plus 2 electrons. This was our 1/2 reaction. Okay. The other side is what we've now found. All right. And if we write it down, it's going to be Cr207 minus 2 plus 14H plus 6 electrons is going to go to 2Cr plus 3 plus 7H2O. Can you see? That's the reaction that we just found out on this side, isn't it? Okay. There's the 6 electrons gone in, and there's balancing out the charge. All right? So that comes from the other side. Then what do? We say, whoa, hang on. 6 electrons on the left-hand side and only 2 on the right-hand side. So I've got to multiply the top by 3, haven't I? Okay. Let's times it by 3. So that's going to be 3, 3, and that's going to be 6 electrons. Okay. Now we just basically add them. Right. Equation 1 plus equation 2. So we say it is Cr207 minus 2 plus 14H plus 3S minus 2. And remember, the electrons have now cancelled out. Is going to go to 3S plus 2Cr plus 3 plus 7H2O. Okay? And what have we got at the end of the day? Let's just check. Okay, we've got everybody in. There's the acid that we had, and there's the water side of it that we used to do the balance, and we've got everybody else balanced out. Okay, so that is probably the most complex one that you're going to see. It is quite a heavy one, but you can see the steps to go through to follow. Right? If you go back and have a look at this again, follow the steps as I've done them, make the notes on the side, and you'll see the logic actually isn't that difficult. I know this session is much longer than normal. I apologize for that. But with these, where we get into this, it kind of is dictated by the equations that we're doing. Lastly, with oxidation reactions, just as I mentioned, you get synthesis, decomposition, and displacement reactions, right? Synthesis is we make stuff. Basically, decomposition would be, for example, water going down to H2 gas and O2 gas, right? In other words, 2 O's, H2, I'm going to have to put a 2 over there and a 2 over there. You can see what's happening. Water's being broken down. Decomposition, breaking it down. In other words, an ore, breaking it down. How much, if you remember the stoichiometry that we did, percentage yields, that's what comes out of it, right? The last one is a displacement reaction, where, and if you remember back to grade 8, 9, maybe, yeah, I think there you did the reactivity. You had a reaction like this, zinc solid plus copper sulfate, aqueous, right? Going to, remember, zinc sulfate plus copper solid, okay? You can see what happened in this one is the zinc displaced the copper. The zinc took over copper's role and the copper precipitated out. This is a very important reaction, as is that one. Okay, that's why I've put them down. those are ones that you're going to see coming up in the next section of this, maybe the bit that I'm going to add on later, or next year. Very important reactions, that displacement and the other one. Once again, sorry that this was a much longer session. We've been trying to keep them all to 20, 25 tops, but we had to go through with that. Okay. As I say, we're going to load in a little more at the end and some more examples going through it. I'm going to be making one or two corrections after we've done some proofreading or some proof editing, I guess it is, post-edit. That's what they call it. So please have a look at this. This is a very, very important section. Hopefully it's kind of coming through to you now that, once again, it's a recipe. It's how we approach it. And you'll see that you can distill the recipe out of this one. We've gone through it time and time again. Thanks for listening. I'll be back and we'll do some more work. And hopefully chemistry is enjoyable as physics is. I'm now going to start on the mathematics side. I'm not sure if we're going to do AP or we're going to do the others. Or possibly even start looking at some grade 10 or grade 12.